Okay, let's talk about cosecant and secant. I'm going to do this in two parts because I want to make sure that we get it done right. So anyway, let's talk about cosecant first. So this is basically the parent function of what a cosecant looks like. But here's the deal with this. Cosecant is the reciprocal of sine. So if I want to graph y equals cosecant, the first thing I do, I graph sine. Now, we're graphing the most basic version of sine because this is the most basic version of cosecant. But the thing is, if you are really good at sine and cosine, then you are going to be really good at cosecant and secant. Let's begin. A normal, non-messed with, everything legit version of sine looks like this. And I'm going to graph it over 2 periods just so you see it. But the ones in the book, they only graph over 1 period. So here we go. It starts at 0. A sine graph starts at 0, and I'm not messing with it. I go pi over 2, I go pi, I go 3 pi halves, I go 2 pi, there I am. That's the end of the road for sine. Goes as high as 1, goes as low as -1. It starts on the line, then it goes above the line, then it goes back to the line, below the line, on the line. And this is my sine graph. It looks like this. Okay? And if I wanted to graph it over 2 periods, I could go backwards. I could go negative pi over 2. I could say negative pi, negative 3 pi halves, negative 2 pi. I just want you to see what this looks like. And then we go down because we're going to just repeat this pattern, but I'm going on the opposite side here. So it just keeps its wave form going. It just does that. So there's 2 periods of sine. Here's the deal. Cosecant. Cosecant is equal to 1 over sine. So there's some problems, and they occur right here. I'm going to grab my blue pen. See, wherever sine is 0, cosecant is undefined. Wherever sine is 0, cosecant is undefined. So guess what that means? It means there is an asymptote at that location. I'm going to do it over here. All right. So in the book, here's the nice thing. They don't ask you for 2 periods. They don't. But everywhere sine is 0, so everywhere sine crosses the x-axis, cosecant is undefined. It has an asymptote. And you know that there are certain locations where cosecant and secant are the exact same number. Those are the ones I'm marking right now. See, if sine is equal to 1, see right here, sine is equal to 1, well, what's the reciprocal of 1? It's 1, so cosecant's equal to 1. When sine is equal to -1, well, cosecant's equal to -1. The reciprocal of -1 is -1. Now, I'm going to get rid of those arrows, get them out of my way, because they're going to be in my way when I graph my cosecant. Check this out. Cosecant is the reciprocal. So where sine is going down, cosecant is going up. Where sine is going up, cosecant's going down. I said it. I haven't drawn it yet. Just bear with me. I'm going to start on the far right, and then I'm going to go towards the left. But where sine is going up, cosecant's going down. Where sine is going up, cosecant's going down. Oh man, that's supposed to be symmetrical. Let me see if I do a better job on the next one. Okay, so in the next spot between the two asymptotes. You can see the sine graph's going downward. That means the cosecant graph is going upward. And I'm trying my best this time to make it look like the two sides are symmetric. That's a better look. That's a better look. It's like a perfect U. So here, on this location here, sine is going up, cosecant's going down. Sine is going down. See how sine is going down there? I'm trying to illustrate that. Well, cosecant's going up. Sine is going down, right? Oops, I didn't want it to do that. So cosecant's going up. So, the black graph, that is my guide graph. That's my sine. The only part that is truly cosecant here is the red part. So the only part that is really cosecant graph is the red graph. Okay, so that's what it looks like, a bunch of U's. That's what it looks like. I graphed it over 2 periods. You don't have to graph it over 2 periods. If they just wanted 1 period, I could have just gotten rid of the whole left side of this picture if I wanted to. In fact, I'm going to try and do that surgically here. I'm going to try and see if it probably won't work. I have a feeling it's not going to work. Oh, it worked okay. It took away my x-axis, though. That's what I was afraid of. Hold on. Let me get my black pen back. See, it took away my x-axis. But there it is. So anyway, guys, that would be 1 period of the cosecant graph. Oh my gosh, it took away that too. I accidentally grabbed some parts I didn't want to. And once again, height of 1, depth of -1. So, let's take a look at secant. And since we spent a lot of time on this one, secant's going to go a lot quicker because here's the deal with this. If I am going to graph secant, my guide graph is cosine. So what do? I first graph cosine. So here we go. I'm just going to do 1 period of this because I don't want to waste a lot of time. Oh, come on, really? Come on. There we go. So here we go. If I graph a cosine graph, 0, pi over 2, pi, 3 pi halves, 2 pi. That would be 1 period of my cosine graph. It reaches a height of 1. It reaches a depth of -1. But cosine starts above the line. And then it goes on the line. Then it goes below the line. Then it goes back on the line. Then it goes above the line. So if I graph 1 period of cosine, it's going to look like this. And then here's the difference between what a cosecant and a secant looks like. Well, once again, secant is the reciprocal of cosine. So if I go 1 divided by cosine, I get secant. So just like we had with the sine graph, just like we have with sine, when cosecant equals 1, height of 1, well, that means the reciprocal is also 1. So secant and cosine are the same there. Same thing goes with -1. So at these 3 darker locations that I just drew, and heck, I'll do them in red. At these 1, 2, 3 locations, secant and cosine are the same. But anywhere cosine is 0, secant is undefined. And if it's undefined, that means it has an asymptote there. And you're going to see a very similar situation that you just saw with the first one we did, the cosecant. Guess what? I'm going to grab a red pen. Everywhere cosine is going down, secant's going up. everywhere cosine is going up, secant is going down. So I'm just going to sketch in both sides here. And then on this one, guess what? It goes like that. Now, that would be one period of that secant graph. That would be one period of the secant graph. So I'm just going to knock out a couple more. Let's play with this because guess what? If you know how to graph cosine or sine, you can graph any secant or cosecant. That's why we spent 3 whole lessons on sines and cosines. Because if you got that established well, then this falls right into place. So let's play just a little bit more in this video. And this one is called Part A, because we just kind of meet and greet the function. But you're going to see stuff like this in the work. It's going to have something like -2 cosecant 1/2 x, something like that. And you go, oh, now there's more stuff to it. There's a flip. There's a flip. There's an amplifier. There's a period adjustment, but there's no phase shift. Okay, there's no phase shift. So let's grab that period. Let's go, you know what? My job is to do the same thing. 2 pi divided by b. Hey, my period's 4 pi. That means my graph starts at 0, ends at 4 pi. But it's based on sine. So my job is to graph a sine graph first. So I'm going to, come on. I hate when that happens. Come on. There we go. There's my y-axis. Here comes my x-axis. And you'll notice I'm all on the right-hand side because I know it's going to start at 0. I know that. And my period is 4 pi. So I go, you know what? 4 pi times 1/4. I'm going to be counting by pi increments. And I don't have any phase shift nonsense to worry about. So I go 0. I go pi. I go 2 pi. I go 3 pi. I go 4 pi, and that's where I stop. I'm going to reach a height of 2. I'm going to reach a depth of -2. But I'm going to have to graph my guide graph. My sine is going to have to be flipped. I start on the line. I do. But then I go below the line. Then I go back to the line. Then I go above the line. And then I go back to the line. And I'm going to graph that sine graph in a flipped position. And that means I'm going to have how many asymptotes? How many asymptotes will I have? I'm going to have 3 asymptotes. So I got 1 here. I have 1 asymptote right there. I have 1 right here. And I have 1 on the end here. All right. And let's grab a red pen. And everywhere my sine guide graph is going up, my cosecant's going down. And it's symmetric on both sides. It looks much prettier that time. That was a pretty darn good drawing. And once again, remember an asymptote is a boundary marker, so it's getting close to that line, but it's not breaking through that line. And that right there is a picture of -2 cosecant 1/2 x. And I can tell because clearly marked increments on the x-axis, clearly marked on the y-axis. Asymptotes are drawn in. Guess what? That's a big, big thing. Make sure your asymptotes are there. And you'll notice in the book, when they show you this picture, they are not going to have the guide graph there. They're not going to have the sine or the cosine graph in there. I don't care if you leave the guide graph. I don't mind, but I do want you to tell me this. When you finally finish it, just like say, red graph is my answer, or something like that. Or get a highlighter pen. Like here, if I want to, I can highlight, and I can say, the highlighted part is my answer. Okay? Like up here, I look at this and I go, whoa, as long as you let me know, this is the part that has highlighter pen on it, is my answer. That kind of thing. Let's try one more that has a little bit of everything, and then in my next video I won't have to go into so much depth because you'll already have established this idea. Come on, black pen, thank you. And let's do one with a phase shift in it. So let's take a look. There's going to be something in your future that looks like this. One plus secant, I don't know, 4x plus pi 4, something like that. What the heck? And okay, let's graph this thing. It's a secant, which means I'm going to have to treat this like a cosine until I get my asymptotes drawn in and everything, and then I can sketch the other one. So, let's begin where we began. This time we have a phase shift, but I need to know my period. I need to know that. So it's going to be 2 pi divided by 4, because that's my b value. So this guy, reduce it a little bit, it's pi over 2. So I start at 0, and then I have this phase shift, and it ends at pi over 2. But you know what? I could have left it as 2 pi fourths. I didn't have to reduce it right away. I don't know if you guys see this, but then I'd have common denominators when I subtract here, but I guess it's not too bad. Whoops. So I end up with, this thing starts at negative pi fourths. It stops at pi fourths. But let's see, what are my increments going to be? If I take my period times 1/4, my increments are going to be in eighths. So I have pi eighth increments. So I'm going to be counting by eighths. So you know what? I'm going to change these guys right here. I'm just going to say this thing is at negative 2 pi eighths, and then it's going to stop here at regular 2 pi eighths. I think that'll make my counting easier. And we already did this in the sine and cosine lesson, so we've done this. We've seen it. I'm going to draw this picture over here, and it looks like I have equal spacing on both sides of my graph, so I'm going to try and do that. Come on. Ugh, I hate when it does that. Come on. Really? You're not going to turn into a perfectly straight line? One more time. Let's try this, please. There you go. Thank you. All right, so I noticed that I have a vertical shift. So, heck, you know what? I'm going to grab a green pen because I got all kinds of stuff going on. So I'm going to go up 1 unit, and I'm going to mark that and say that is my center line, and that's at 1. I know that my graph is going to go 1 unit above that, so as high as 2. It's going to go back down to 0 because that's my amplitude. My amplitude is also a 1. And then I already have my starts and everything, so let's go grab some red pen. I am going to mark this off and say, or wait, sorry, black pen. I'm just trying to make it color-coded and pretty. And I am going to count by eighths. So I'm going to have to go back 1, 2. So it's at negative 2 pi eighths. I'm going to just reduce it in my head and say that. This would be negative pi eighths. That is 0. Then I have one over here at pi over 8. And then I have another one at 2 pi eighths. I'm just going to call it pi fourths. Remember, because that's where it starts, that's where it stops. That's where it starts, and that's where it stops. And I'm looking, it says here, graph each function over 1 period is the instructions. So that's going to be good enough for us. Here we go. I am graphing a cosine as my guide. So I look over here and I go, I'm not going to start on the line. No, no, no. I'm not going to make that mistake. I'm not going to start on the line. I'm going to start above the line. So I'm going to go above the line, on the line, below the line, back on the line, above the line. And I have my cosine graph. That's my guide to help me graph this function correctly. How many asymptotes do I have? I have 2. I have one right here, where cosine crosses the center line. I have one. Where cosine crosses the center line. I have one. And then I'm going to grab my red pen and finish this graph off. Where cosine is going down, secant's going up. Where cosine is going up, secant is going down. And vice versa. All right, so the red graph is my answer. Or take your highlighter pen and give me one of those and just say grade the highlighted part. But once again, what am I looking for? All of this stuff to be correct. I want to see all of your markings. Now, you don't have to write the word start and stop, but you might want to, because I have news for you. When we get to the next video, you'll see the answer key from the book. They did something a little bit weird, but I don't think it's going to be that tough for you. I think you'll be able to handle it, and we'll talk about it when we get there. Okay, so this is part A. We're going to part B next. Thank you.